Floating around Earth is an estimated 170 million pieces of undetectable small debris. If we don't find ways to track these destructive debris, future collisions could cause a chain reaction, potentially filling up near-Earth orbits, and threatening the sustainability of satellite launches and space travel.
So today we have visitors from University of Michigan performing their experiments using the Nike laser at the U.S. Naval Research Laboratory. And University of Michigan is going to be using this platform for studying signatures that are generated when objects at this very high velocity collide with each other. You don't see the start of it.
It turns out that on Mars there are these dust storms that cause superficial dust to just rise in orbit. And as they're rising, these tiny little dust particles hit each other.
Basically, there is an exchange of charge in the collision. When the parts start moving away from each other, there is a spark. They produce electromagnetic signal.
Professor Nilton Reno, a Mars expert at the University of Michigan, who was part of the team that discovered liquid water on the red planet, originally discovered this dust collision phenomenon. As the Intelligence Advanced Research Project's activity called for proposals for researchers to develop ways to track small debris, these Martian dust storms got him thinking, what if debris in space emits similar signals?
And then one day I realized, well, debris collide with each other very likely. How frequent do they collide with each other? So I did a very crude order of magnitude calculation. And I was surprised. The number of collisions that I got is the order of 1 per second in certain orbit. And then when I realized that at those orbital speeds, the collision is going to generate this plasma plume that expand quickly, then I estimate just very simple, I like simple calculation. They are crude, but easy to understand, that the basic physics show that the signal is tremendous. That's the first time that I realized this is going to work.
As IARPA continues to explore ways to track small debris, Reno and a team of climate and space engineers are putting this idea to the test. Using computer simulations developed by research assistant Yun Zhang, they're able to visualize what signals are produced when small debris hits other small debris or larger known objects.
Based on our simulations, we found that the signal that was generated from the collisions can range from even optical to radio frequency. So it's a broadband signal. And the optical emission mostly comes from the heating of these debris. And the radio frequency will mostly come from the plasma that was generated during the collisions.
To validate these simulations, the team needed to recreate space debris collisions in the lab. They fired a laser beam at a tiny piece of aluminum foil, about 1 millimeter in size. The energy fired at the foil launched it into an aluminum plate at 22,000 miles per hour, roughly the speed at which junk collides in space. A radio antenna and other sensors detected the electromagnetic signals emitted during the collision, and the entire experiment took place inside a large vacuum chamber to help mimic the vacuum of space. After a series of tests, they were able to detect the same radio and optical signals the simulations predicted.
I think in the proposal you have to estimate how certain are you that this technique is going to work. I said 50%. And then the more we look at it, the stronger the signal appeared to be. So that was a very nice surprise.
These signals could be strong enough to be detected with the very same telescopes and antenna the Space Force uses, which could allow them, for the first time, to detect and track debris smaller than 4 inches.
If there is data coming in that can see objects that are smaller, we can identify risks, hazards, and potential threats to spacecraft that are in space. So I think it would be a great benefit to all global space users if such technology existed to identify even the smallest speck of debris or smallest speck of object.